Hello, this is Takeshi Kurata from AST Japan. Today, I'd like to talk about analyzing operations on the manufacturing line using geospatial intelligence technologies. Health and productivity management (HPM) is realized by simultaneously improving labor productivity and quality of working (QOW) in a well-balanced manner. Since it is necessary to deal with a wide range of issues for that, engineering and DX approaches are essential. On the other hand, it has been reported that 60 to 80% of information is related to location information and that humans spend approximately 90% of their time indoors. Therefore, Geospatial Intelligence (GSI), especially indoor GSI, it supports problem solving by linking geospatial data with other data is expected to be an effective means to promote DX and HPM. In this presentation, I'm going to report on a case study of work analysis using indoor GSI technologies conducted on manufacturing lines at a JPS plant. An indoor positioning system and PLC were installed to collect data to determine the position of each worker and the state of each equipment. The main objective of this work analysis was to investigate the feasibility of improving the operation rate, automating work records, and visualizing work transitions, and also to confirm the value of work skills. From the perspective of HPM, 1 to 4 are all related to productivity, and 2 to 4 are related to QOW. The ground truth GD data were prepared manually by visual inspection using recorded video for 3 days of work. Only this GD data have both the manufacturing line ML axis and the worker axis. And handwritten stoppage factor record (HS records) are daily handwritten record kept by workers in the workplace. The quasi-GD data are generated by integrating the HS records and the PLC data using the method explained later. Since both HS record and PLC data are constantly obtained on site, they can be easily scaled up. The estimated data are the estimation result of a method based on machine learning, LSTM, using PLC data and positioning data. All 3 types of data are only along the ML axis. This slide shows the breakdown of work classifications such as MR, material replenishment, OP operation, setup, S-series, as well as the GD values and work shift overlaps for workers 1, 2, and 3. The HS record contains no missing data along the ML axis. However, there are 2 significant issues. One is that the start and end times of each work record are rounded off, and the other is that material replenishment (MR) work are not recorded, even if MR is one of major stoppage factors of MLs. Meanwhile, because IoT transition is still underway in the workplace, PLC data that can be sent to the server and used for analysis are limited. In this case study, we developed a method to generate quasi-ZD data that are more accurate in time and include MR works like this. I will show you this MR detection process with the next slide. Actually, this MR detection process is also used to extract one of PLC-based features for LSTM. Anyway, with PLC data, it is possible to grasp each status of out of material and open and closed status of the equipment cover, so their combinations are used in the detection process. The accuracy of the quasi-GD data generation method was evaluated by comparing the HS records, GD data, and quasi-GD data. The quasi-GD data can be generated with an accuracy of 92%. This is better than HS record, and we can automatically record operation and MR with 96% and 93% respectively. We conducted work analysis using the quasi-GT data and GT data instead of using the result of the work classification estimation by machine learning, explained later, since it was still in the feasibility study phase during this case study. Anyway, first here is about the quasi-GT data-based analysis on the ML axis. This figure shows a state transition diagram of the work classification, that is a work process model. The transition from OP, operation, clearly identify that the major stoppage factor is MR, and that the main setup workflow after operation is SC to SA or SD, then to SE. Since it is possible to perform simulations based on such models, preliminary evaluation with the model are expected for efficient Kaizen improvement of these manufacturing lines and similar lines in the future. As shown in the left graph, there was a weak positive correlation between the operation rate and the continuous operation time within each operation cycle. This result implies that longer the continuous operation time is, the higher the operation rate is. As each ML requires a brief stop for MR, we also analyzed MR and approaching actions to the equipment for MR. Comparing the HS record with the quasi-GT data confirmed that 34% of time for operation in the HS record were actually MR, and also it was found that approaching time obtained by MR work detection process amount for 36% of the MR time. If all approaching time that take longer than the median were replaced by the median, the operation rate could be improved by 3%. We also compared differences in operation rates depending on whether MR was passive or active. A passive cycle is one in which all approaching actions are carried out after the material runs out, and an active cycle is one that includes MR studied before the material runs out. The analysis confirmed that the median operation rate for passive and active cycle are 47% and 49% respectively, and that variation in operation rate are greater for passive cycles. Here's about the GT database analysis on the ML and the worker access. The findings are like first one, WIP, work in progress output adjustment, occupies about half of the time in operation. Then second, the ratio of manual work record, MWR, in operation to the one except in operation is 2 to 1. And about half of cleaning of garbage disposal, CL, is done during internal setup. So, for example, if workers for shift 1, 2, 3, and 5 works similarly to the high-skilled worker in shift 4, WA can be replaced with other works such as MWR and CL, and the ones in operations can be increased by 8% of time for operation. Although this 9% is only an average, this 8% is expected to be within this 9%. Here is the summary of this case study. For the rest of this presentation, I briefly introduce automatic work classification based on LSTM. This work classification method based on LSTM uses 47 features based on PLC and then 9 features based on positioning data. As for these position-based features, we designed distance features representing travel distances. For efficient computation, maps of travel distances from each equipment are pre-computed as in this figure. The purpose of work classification estimation was to automatic data generation comparable to the quasi-GT data. So the comparison target here was the quasi-GT data. As a result of evaluation, the accuracy was about 91%. While operation and MR are highly accurate, there was some room for improvement for estimating setup-related work classes. That's all. Thank you for your attention.